A hearty welcome to everyone. Hoping that I am clearly visible to everyone here. So, we are trying our best to represent ourselves while teaching online. Yes, we know that the video teachings are not so much effective directly on the board. So, we are trying something new, and due to that perfections, we were not until here. So, today, as you all know me, myself, Mr. Samir, sir, I'm going to start the topic light. Yes, we will revise the short concepts, we will revise few things in short here, and we will come to know about many new aspects of light too. So students, today we will start with our chapter. As we all know that since childhood we are studying light, we are knowing about light, what is light in general in short. Suppose that let us consider this is a sun and this Mr. Sun gives some radiations. These radiations fall. Here suppose you are standing over there. Yeah. And here are suppose a tree. Okay, I shall change it. Suppose this is a tree. So when this light, when the rays fall on it, then you can see over here. You may have the objects visible to your open eyes here. So the phenomenon in all for which we can see that things we call it as light. So coming to the topic, let us start the topic today. So light. So what are we going to study in this unit today? So here we are going to study about the properties of light in today's lecture, the reflection of light and the refraction of light. We are going to cover our three concepts. The first one about the properties of light, second would be about the reflection, and third would be about the refraction. We will be studying basically what light is. Then we will be talking about the features and the nature of light. And finally, we will be speaking about the reflection and the refraction and the phenomena. As we all know that light always travels through a medium. Light needs a medium to travel. So, getting started with the topic, let us move to the topic of us. So, what is light? In general, what do we call light? Light is a form of energy which enables us to see or help in our vision. Generally, we can say that for hundreds of years it was controversial about light. No one could describe what light is. But nowadays we can say light is a form of energy. It is completely a form of energy. We know that the forms of energy, heat energy, light energy, electric current, these are all the forms of different forms of energy. So light is also a form of energy, and that helps us in vision. In vision means to see the objects. We can see the objects over there. The objects which we are having in the nature that can be visible to our eyes, this vision, we call it as the visibility. The objects are visible to our eyes due to the light only. So let us move to the next one. Now what are the properties of light? Actually Newton had proposed that light is in the particle form. न्यूटन ने बताया था, न्यूटन ने क्या कहा था? Let us talk about what Newton said. Newton said that light is in particle form. Then who comes? Then comes Huygens. Huygens proposed the wave nature of light. Huygens proposed the wave nature of light. Then comes Planck, who proposed the particle nature of light. Planck proposed the particle nature of light. But nowadays we consider light as a dual nature. Nowadays, recently, we are considering light as dual nature. Why light is in dual nature? Because it behaves in particle form as well as it behaves in the wave form too. While it is interacting with the matter, it is in the particle form, and when it is interacting with waves, it behaves as a wave form. So we can say that we may have different considerations about the nature of light, but light is in dual nature. So in short about the property, this light always travels in a straight line. Suppose there is a single point over here. From that point, the light goes on traveling in a straight manner. It travels in a straight path. So this light travels always in a straight line. It does not go in this form. It will not go in the random form too. The light will always keep traveling in its straight line path. So we can consider it with the help of the laser itself. So the next thing which we want to talk about, that is the speed of light. As we all know that light has a very great speed, and its speed is approximately up to 3 lakh kilometers per second. We can write it as in the form 3 into 10 raised to 8 meter per second. This is the speed of light, standard speed of light. And at this speed, we can say that the light can go around the world 8 times in a second. Suppose this is our earth. So if light is traveling, it may completely take 8 rounds in 1 second around the earth. That much is the speed of light itself. So this was about the speed of the light. Now let us talk about few things, that how this light travels, or what speed does it take place, and what are some interesting facts about light. So for example, we can say that as we are telling light travels much more, it travels larger than the sound itself. You may have heard thundering and lightnings may have been seen when it rains heavily. At that time when the rains rain or when the clouds thunder, at that time you see the lightning first and then you hear the voice of thunders. So this lightning, instant flash of lightning is visible to our eyes first. So this is the example that can be comparatively studied how light travels at a great speed. So talking about the interesting facts about light, first of all, we should know light is an electromagnetic wave. What is light? Light is an electromagnetic wave which possesses energy and has ability to produce sensation of vision. It means this electromagnetic wave gives us vision itself. Then another one more important thing, this light wave is a transverse wave. This light wave is a transverse wave. Remember always. And it does not need material medium to travel. Light can travel in vacuum also. Light can travel in vacuum, air, water, glass. So it means that light can travel even without the medium too. It may travel in vacuum. So we can say that it does not need a material medium to travel itself. So then few more interesting facts about light. This light travels in a single manner, then it is a ray. But if bundle of rays travel together, it is called a beam. Just before some time we said that suppose this is the source. From here the light is traveling in a straight line. If this light is traveling in a straight line in a single one, this is known as the ray of light. But when it travels in number of rays. Suppose that there are 2, 3, 4, 5, 6, 7. We don't know how much are these. Infinite number of rays travel here. Then these rays togetherly, they are known as beam of light. What are these known as? Beam of light itself. So let us move to next one. Due to light, we see the things, and that is the phenomenon. Why? Because light reflects into our eyes. When the light comes from the sun, it falls on the object. These light rays coming, they fall on the object itself, and then these rays travel up to our eyes. When these rays travel up to our eyes after falling from the sun, then only we can see the objects which are present in the nature. So there we can say again, there are two things about the object. The objects which are visible due to the falling light, or let us say that the objects which are visible due to the source of light, they are called non-luminous object. What are those objects called? Non-luminous objects. And if suppose that let us consider the objects, if they are visible to our naked eyes directly within itself, which objects produce their own light? Objects producing their own lights. Object producing own light. Then these objects are specially called luminous objects. What are these objects called? Luminous objects. So basically there are two terms, one non-luminous objects and the second one luminous objects. What are non-luminous objects? Non-luminous objects are those objects which don't have their own light. And what are luminous objects? The objects which have their own light, or which produce their own light. They are luminous objects. Now when the light rays fall, there are some barriers. Suppose the light rays coming from the sun, they fall on any object. When they fall on the object, these rays of light produce their image in our eyes after reflecting over here. Okay, suppose this is our eye, we are watching it. But these light rays are completely reflected from over here only. It means that this object is the barrier within its own. The object is the barrier within its own. Then at that time these rays do not pass. These rays do not pass the object. Then the object creates a shadow of itself. The object creates a shadow of itself. It means we can say the places where light is blocked. Shadows are the places where the light is blocked. Now let us talk about or summarize about the properties of light. The first thing we talked, light travels in a straight line. Light travels much more faster than the sound. We see things because they reflect light into our eyes itself, and shadows are formed when light is blocked by an object. These are the few important facts about light. Now let us start about the phenomenon. What is the phenomenon of light? The first one, reflection. Suppose that this is a plain glass sheet over here. You can see over there, this is a plain glass sheet. Just excuse me, let me change the color. Okay, it would be more appropriate. See, this is the plain glass sheet over here, and on this plain glass sheet, one side is coated with one side of this glass sheet is coated with a thin layer of silver metal. This is coated with the thin layer of silver metal, and this is called a plane mirror. This glass sheet is known as the plane mirror. Here you can see it. This is called mirror. So when the light rays fall on it, let us consider that this is M and M dash, let be the mirror in itself. It is fixed horizontally. So when the light ray, a ray, suppose incident ray is here, a light ray Pn would be falling on it. What color should be for N? Okay, you can see it now. A light ray Pn is striking on the mirror. This striking ray is known as the incident ray. This striking ray is known as the incident ray. And when it strikes at the point where it strikes, from there let us draw a perpendicular line to the mirror. That perpendicular line is known as normal. What is that known as? Normal. The dotted line, let us call it as N to N dash. This dotted line on the mirror is known as the normal. Then the ray NQ, suppose from here, this ray NQ, it is passing or it bounces back from the point N, which is called reflected ray. This bouncing back ray is known as the reflected ray. And the angle between these two, the angles which are being done over here, this angle P, N dash, this angle is the angle of incidence, and the angle which is over here, this angle is the angle of reflection. The angle between this incident ray and normal, this is angle of incidence. The angle between the incident ray and the normal is the angle of incidence, and the angle between the reflected ray and the normal is known as the angle of reflection. Let us clear it with a blank slide yet. So let us draw one more figure here. Suppose this is a mirror. What's the problem? This is a sheet of mirror. A ray is falling over here. Let us consider this line is the normal and this ray is reflecting back from here. The ray which is falling, this ray is the incident ray. What is this? Incident ray. And the ray which is bouncing back, this ray is known as the reflected ray. This is the reflected ray. Now, the angle which is made between the normal and the incident ray, this angle is angle of incidence. This angle is angle of incidence, and the angle made by the reflected ray and the normal, this angle is the angle of reflection. Okay, so we have talked about it. Here we must know the angle of incidence is always equal to angle of reflection. Why so? The law of reflection tells us that when the light rays make an angle with the normal, the ray which has been penetrating on the mirror, that ray and the bouncing back ray, these both ray make an equal angle with the normal. They are both the same. You may see over here, this angle of incidence and the angle of normal, they measure both the same. In other words, we can say that light gets reflected from a surface at the same angle. Therefore, angle of incidence is equal to angle of reflection. Symbolic form we can write it, angle of incidence is equal to angle of reflection within its own. Now the incident ray or the reflected ray and the normal, they all lie in the same plane. If suppose you are watching over here, this incident ray, the refracted ray and the normal, these all three things are in the same plane. Let us show the plane. See over here, this is the plane of them. So this is the ray which is incident, this is the reflected ray, and this is the normal. These all lie in the same plane. So let us say that angle of incidence, angle of reflection and normal, incident ray, reflected ray and normal lie in same plane. See, we can see over here, this is the mirror, the incident ray is falling here, the reflected ray, angle of reflection and angle of incidence are shown. These are all the things in the same plane. They are not changing their frame of reference or they are not changing their plane. They are all in the same plane. So these laws are applicable. This is applicable to both the mirrors. Which one? Suppose let us call them as this is applicable for plane mirrors. Also, this is applicable for spherical mirrors, which we want to learn in the next upcoming topic. And also it is applicable to the parabolic mirrors. It is also applicable to the parabolic mirrors. But now this reflection occurs based on the surface. See, this is our plane mirror. It has a very plane surface. But if the surface is diffused, then the reflection occurs different. What is a clear or regular reflection and what is the diffused reflection? Suppose that the surface is very smooth and shiny, then we have a clear reflection. The rays, they fall on it directly in a straight line, and the rays, they get reflected back, that too in a straight line. But if the surface is dull, if the surface is rough, at that time the reflection occurs diffused. The diffused reflection is when light scatters in different directions. Suppose these are the rays which are falling on it. These rays are falling on it, okay. But now these rays are not bounced back with the same angle of the incidence. They are bounced in any direction, in anywhere. They may be bounced in any direction, in anywhere. Then such reflection is known as the diffused reflection. Such reflection is known as the diffused one. So now talking about refraction. What is refraction? Suppose that a light is traveling, any light ray is traveling from a particular object, from a particular medium, and suddenly that changes its medium. Suppose this is air and this is a glass over here. This is a glass. So this light ray which is traveling, this light ray suddenly changes the medium. See, here it is air as a medium, here it is glass as a medium. When the light rays change the medium, then they are slightly bent. They get slightly bent or they slightly change their path. This particular phenomenon is known as the refraction. So when does the refraction takes place? When waves bend or slow down due to traveling in different medium. While traveling in different medium, the waves get bent or slow down. Then you know what is medium. A medium is something that wave will travel through. If light is traveling through the air and suddenly it is traveling through the glass, so here it will not go in this line straight in this manner. It will not go. It is not necessary there. Then the light will change its path slightly. This will take a new path. So this is the refracted ray. This is the refracted ray. So here the light gets deviated. The light changes its path slightly. So this phenomenon is known as refraction. You may have seen that when an object or a pen, suppose this object is kept in the tub, the appearance of the outer surface and the inner surface, they both are in different one. So in this case we can say that light rays are slowed down by the water and they are bent. You may see, if it is visible to you properly, then you can see over here this gets bent over there, okay. The pen to look odd. The two mediums in this example which are given, the first one here, this is the air medium, and here in the tub itself it is the water medium. So we can say when light rays change their medium, they are slowed down due to the change in medium and they cause a bending there. They cause a bending of ray. This ray gets slightly bent. This ray gets slightly bent. Instead of going straight, it gets bent. This is known as refraction. So what are laws of refraction? Here in laws of refraction we can say the angle of incidence and the angle of refraction, about them we are talking. So before that we should talk about incident ray. The ray which falls on the normal, that is incident ray, and the ray which moves or gets bent, that is the refracted ray. These all lie in the same plane. Here too, incident ray, refracted ray and normal, they all lie in same plane. According to Snell's law, when Snell talks about it, he says that when angle of incident and angle of refraction, if the ratio is taken over there, we get a constant. He says on the ratio of angle of incidence and angle of refraction, we get one constant over there. That is Snell's constant. So refraction of light, when a monochromatic light is passing through the prism, here suppose this is a monochromatic single slit white light, let us call. Okay, this light ray, it is passing on the prism. When it falls on the prism, the light rays split, and these light rays are split into 7 different colors. We call them as VIBGYOR. What do we call them? VIBGYOR. We write there VIBGYOR: violet, indigo, blue, green, then yellow, then orange, and then red. So this is the bandwidth that we get when the light rays get refracted from the prism itself. So what is the phenomenon behind it? When the angle of incidence is falling there on the normal itself, the ray with the normal, instead of going straight here, instead of going straight, it will bend a little. This ray will bend a little. Suppose that you may see a white light is entering over here. Okay, this white light is entering here. Instead of going straight here, instead of going straight over here, this light gets bent. ये light क्या हो रहा है यहाँ पे? Bent हो रहा है. This light gets bent over there. यहाँ पे अगर आप देखो properly, तो you will see the bend of the light. This would be the imaginary light that would pass straightly, but this is the bend in the light or the deviation in the light, and then this splits into the spectrum itself. Its constituent colors are seen upon the refraction with the deviation. Here, this deviation, we can say the red has the deviation that is the least, and the violet has the most. We can say the red light which has the least deviation, and the most deviation is from the violet light itself. So while they are splitting, what is the exact measurement of this light? So the bandwidth for the violet light, I am talking about the violet light, it would be about 4 nanometers, let us call it as 4 into 10 raised to minus 7 meters, we can say. And about the red light when we are talking, then its wavelength would be 7 into 10 raised to minus 7 meters, in this manner. Different colors are remembered in order of their increasing. We call it as a rainbow. We also call it VIBGYOR in short. This was the phenomenon of refraction. Here are the given colors of the rainbow itself. So let us write the intensity over here. The wavelength itself is 7 into 10 raised to minus 7 meters. Then for the violet it is 4 into 10 raised to minus 7 meter. And while we are talking, the wavelength which is less than this portion, the wavelength which is less than the violet one, those are ultraviolet rays. Those are called ultraviolet rays. And the wavelength which is more than the red one, those are infrared rays. Those rays are known as infrared rays itself. So this is an interesting thing of adding colors which is given for you people for the activity. Hoping that you will solve this activity. We will study it in the tomorrow's lecture. let us stop today over here.